Welcome to the Beyond 11 Nines of Durability Data Protection with Amazon S3. I just wanted to mention this before I forget, but we're in the orange section. We got the orange headphones on. I got the orange shoes on. Like, the synergy there is just, it's palpable. We can all feel it. We've got Ian McGarry here. He's a software development manager for Amazon S3. He works on things like our VPC endpoints, replication, networking, load balancers. My name's Rob Wilson. I manage a team of product managers. My team works on things like S3 tables, S3 metadata that launched earlier this week, and then other data lake functionality, security, encryption, batch operations, things like that. So happy to talk about any of those topics after the session. We can do Q&A. We can all chat and catch up with each other. Excellent. So for our agenda for today, we're going to try to cover a lot. But as we walk through it, we're going to talk through a background of 11 nines first. That is the advertised number you see. It's a designed for durability number that Amazon S3 builds for. Ian's going to talk about that. That's a lot of internal mechanisms, checks, balances to make sure everything's stored correctly and maintained that way for a long period of time. Next, we're going to transition to what is data protection. So we know what Amazon S3 does to protect your data, but what can you do on top of that? What features can you use? What other functionality can you use to add additional data protection and protect against certain scenarios, things like overwrites, accidental deletions? Then we've got a slide. I'm calling it the continuum of data protection. So things you can do within a single bucket, and then things that allow you to add additional data protection across regions, across accounts, and gives you that additional level of resiliency when you think about storing data and storing critical data. Then we're going to talk about protecting against those accidental deletes, overwrites, and lifecycle expirations. So if something's unintended on the lifecycle side, how can you protect against that as well? Then we're going to transition, like we talked about, the cross-account, cross-region, all of those additional protections. And then we'll recap at the end, go through some additional bullet points, just to make sure you've got a few things to think about today. All right. Without further ado, we'll bring in Ian to talk about the background on 11 nines. This will be the internal checks that S3 does on a day-to-day basis, second by second, I'd say, for your benefit.
There you go. Thank you, Rob.
Oh, you've already got one.
Yeah, I got one. Hey, folks. My name is Ian McGarry. I'm a senior manager on S3. I've been on S3 for about 6 years, and I've worked across a number of spaces, as Rob just called out. It's 4 p.m. on Thursday of reInvent week, and so the fact that you're here means you're very curious, I think, about how S3 works and learning about some of the best practices, so I'm excited to talk to you a little bit about those today. I'm going to talk more about under the hood, how we maintain durability within the service, what are the mechanisms we use. I'm also going to talk about how things fail, how things break, which should be interesting for any of those folks who enjoy that. And then I'll also talk a little bit about the culture and some history thrown in. So let's kick into it. If you've used S3, you probably recognize that number. You don't have to count the nines on the board. That's 11 nines of durability. That's the number that we anchor ourselves around. But internally, we strive to be absolutely lossless, right? And so 11 nines of durability is important to us, but really day to day, we are trying not to lose any data whatsoever. Some interesting, some of the slides I'm going to go through later are going to talk about, well, what are the mechanisms we have to actually achieve that number? But a lot of them are simplistic in their scale to try and break down the problems to their core. But to give you an idea of the scale we operate, that's a lot of where the complexity lies. And I have some interesting stats to share that some folks have shared in the past, but I think are really, really awesome. So the first is we have millions and millions of drives to store your data. If you took all of our drives and stacked them one on top of each other, you would be able to reach the International Space Station several times over. So it just gives you a sense of the amount of drives we manage day to day. The second piece is the amount of data we're processing, or the amount of throughput that is moving in and out of S3 every day. It's well over 1 petabit per second. When I started S3, it was in terabits. Now we're into the petabits. And again, to take a petabit and reason about it, assume the average high-quality image size is 3 megabytes. If you were to think about a petabit of traffic versus that's about 41 to 42 million pictures we are transferring every single second. So hopefully it gives you a sense of the scale that we're operating at, and that's how we think about these problems, or have to think about them. Okay. So there's 3 core pillars that we think about when we're thinking about durability. One is device failure, so that's the actual hard disks that are failing. Then we talk about zone failure or facility failure. That's where our availability zones come into play. We have to be able to tolerate the loss of a full availability zone. And then we also think about people, how the operations we are enacting every single day, the code we're deploying, the configuration changes we're deploying, how they can impact. So they're the three pillars, and we'll discuss in detail each of those three. So very first one, we'll start with a problem statement. This is our drive failure. We must protect data stored on drives that can fail or corrupt bits at rest. Corrupting bits at rest is really just a reality of storage media. When you're storing bits on hard disk drives, they can fail and they can corrupt bits. So we think about that. So what are the actual mechanisms we have to protect ourselves against that? Well, we've got three. The very first one is integrity checks. And this is us checking, using checksums to validate that the data you sent us is actually what we're storing. So that's one really, really important piece. The next piece is data redundancy or data drive redundancy, and that's storing your data across multiple drives so that the failure of any single drive doesn't make your data unretrievable. And the third one then is periodic durability auditing, and so that is checking that the data we've stored is the same when we try and retrieve it. And we're continuously checking the data all the time to make sure that it hasn't decayed over time. That's a really, really important piece of it. That auditing is super important, and I'll go deep into that in a little bit more because especially how we think about storing data over many, many years. Okay, so what does the first piece look like? The end-to-end integrity checking of requests. Let's actually look at a request and the life of it. So you send us a put object request with your data. When that reaches our request plane or our data plane, we take that object and we immediately start calculating checksums on it. And that is to ensure that, again, when we're making changes to this data down the line, we actually are able to go back and verify that the data you sent us is what we're storing. And so along this way, the data is being transformed. It could be encrypted. It could be framed. And then eventually, it gets to the point where we're doing erasure encoding on it, which is where we're taking your data, splitting it into shards, creating copies of those shards, and then storing those across many, many drives. And this allows us to reconstitute the data afterwards. This is what things look like on the path forward, but what about the path back? How do we go and tell you that we've stored your data? Well, we have this process that we call bracketing. And what that means is along the way, we've calculated checksums, we've sharded your data using erasure encoding, and then we've stored it. What we then do is go and recalculate the checksums all the way back to say that, hey, all of the work we've done on it has not changed the core of your data, and we have the same checksums. So we go forward and we calculate, and then we come backwards and we calculate again to verify that the changes we've made to store your data still result in you having the same data you sent to us. That all happens before we finally send a HTTP 200 success to you. So you know that your data is durably stored across many drives with many checksums during that process. If that sounds like a lot of checksumming, it is. We do roughly just over or a bit over 4 billion checksums per second. So that's a lot of compute that's checksumming all the time in S3. But again, durability is super important to us, so we invest that. All right, so that's the end-to-end checksums. The next piece I spoke about was the drive redundancy. So here I've got a very simple diagram. Again, we don't actually have 5 drives. We have a lot more than that. But again, I'm trying to break it down so we can see how this works in reality. So 5 devices, each with different pieces of data on that. So what happens when a drive fails? We've lost the ability to access A, B, and D chunks of data on that drive. But when that drive fails, we use a process that we internally call repair to reconstitute that data onto another drive. So you can see we're pulling chunk A from the first drive, chunk B from the 4th drive, and chunk D from the 5th drive. So that allows us to basically reproduce that data in exactly the same way on that drive. Now, this is, as I mentioned, we call this process repair internally, but we're not actually repairing the drive. We are repairing our view of that drive, which is taking the data that was on it and making sure it's available on other drives. So that's, again, how that's happening at a very small scale. Let's look at this at a little bit of a larger scale. This is an interesting image, and on it you can see that drives are continuously failing, and then we are continuously repairing based on the data being available across multiple redundant drives. On this, you can see that all our drives actually have data on them. So we don't have just a bunch of empty drives waiting for repair. We keep free space across all the different drives so that when we're repairing, we can actually get the throughput of all of those disks together to help repair. So if you're moving data across many, many drives, it helps you have large throughput on repair as opposed to just having one drive where you're shoving all that data on very, very rapidly. So it's happening at a very, very large scale. So that is drive redundancy and what the process we call repair. The third piece I spoke about was the auditing, which is super important. Drives don't just stick up their hand and say, hey, I failed, right? They can become unavailable, which is very easy for us to see because we can't access them and we get errors, or they could be flipping bits silently at rest. And that's the part we worry about. So we're continuously and aggressively checking all of those drives. And how we do that is taking the checksums that we calculated earlier and every so often pulling that data, rechecking the checksum and making sure it matches. And if it doesn't, we know that the drive is flipping bits. So that's a constant process that we're doing. And again, as I said, we can enlist our re-replication systems to say, hey, that drive has flipped bits. Let's treat that as a failed drive, and then we'll repair and retrieve the data elsewhere. So we'll knit this all together, and what we actually get is a rate of failure, which can be drives going offline. It can also be drives flipping bits. And then we have a rate of repair. And what we do is we plug that into a mathematical model, and that helps us actually calculate our 11 nines of durability. So if we have drives failing at a certain rate, we know then that we need to repair at a specific rate to stay ahead of that and calculate our 11 nines. Again, we anchor around 11 nines, but the reality is we stay well ahead of that to ensure we're always meeting that goal. All right, so that is drive failure, which is, again, how we design for our 11 nines. But let's talk about AZ loss. So again, a problem statement. We must protect data we store against the unexpected loss of an entire zone. We assume that any single facility may fail at any time, and that we must still protect the durability of data that is stored within it. Okay, so what does this mean? When we come back to our previous example, but let's expand it out a little bit more, instead of 5, we have 12 drives. This actually represents a region. And when we break it out, we'll have a number of drives in every availability zone. Most of our storage classes are already multi-AZ. The vast majority are, so you don't have to worry about this, but this is how it's working underneath the hood. So 3 availability zones. This can be any one of our regions. And let's walk through a request. Very similar to what we spoke about when we were doing integrity checking. When we receive a request, we are doing the checksumming along the way. We are doing the reverse bracketing to ensure that we are storing exactly what you sent us. But the shards of data that we produce from the erasure encoding and the copies of those are stored across multiple availability zones. And so when we actually return a 200 response to you, your data has been durably stored across 3 availability zones, so many, many disks at this point. And so that's how we achieve, that's how we maintain durability even with the failure of an AZ. Okay, so that's storing your data. What about retrieving it? So we must remain available through the unexpected loss of an entire availability zone. We assume that any single facility may fail at any time and that we must continue to serve requests when an entire zone is offline. So what I spoke about earlier was storing your data in 3 availability zones. Now let's talk about the retrieval. Very, very similar process. We've got our 3 availability zones. You want to retrieve the object that you stored, but AZ3 has gone offline. Well, we have enough shards of data in the other 2 availability zones that we can still reconstitute the object that you sent us, checksum it, and return it to you. And so even when an AZ fails, it's very unlikely that you will notice anything. And this is the availability. It's not durability per se, it's availability because we're talking about returning the data to you. But again, the durability was guaranteed on the put when you stored it with us, and that allows us to tolerate a failure later on. All right. So that's the 200 success. So how does this actually work in principle? When we have a failed AZ, how do we route around that? And I'll talk a little bit about this. This is actually the first space I ever worked in when I joined S3, which was our DNS and routing and networking. So it's very, very close to my heart because we have put a ton of work into it over the years. So it's quite simple on the surface, but again, complex underneath. S3 has DNS names that you've potentially heard of or never seen. Sometimes they're hidden in the SDK, sometimes you're calling them directly. Here's an example for Northern Virginia. It's s3.useast1.amazonaws.com. So if you ran a dig command against that endpoint, you would get back IP addresses for US East 1. If you continue to do that over and over again, you would see that there are many, many IP addresses. And you are getting IP addresses of our servers that are across different availability zones. There's no preference. We'll return them at random to try and ensure that traffic is distributed evenly across the fleet. When we have an AZ failure, such as a power failure or network failure, whatever it might be, we quickly detect that and remove those IP addresses from DNS. And so when you are resolving the endpoint, you're receiving IP addresses only for servers that are healthy. This happens very, very quickly, and that's why it's super important to honor DNS TTLs, or time to live, for records that are returned from DNS. Whenever you resolve DNS, the DNS server will also return a TTL. It's basically to say, here's how long you should hold on to that IP address for. For S3, it's actually 5 seconds, which is very, very low, but we do that to ensure that when we have an AZ failure, it's a very, very short period of time between when you first resolve DNS and you re-resolve, so you're only getting the second time back an IP address that you can actually use. So super important to honor DNS TTLs. Now, again, the SDK does this by default for you, so you don't necessarily have to worry about it, but if you have any custom clients, custom DNS resolvers in your VPC or on-premise, it's super important that you configure them in such a way that they honor S3's DNS as opposed to overriding with defaults. So that's the availability posture and how we route around the failure of an availability zone. But AZ fault tolerance, what we spoke about routing around, and those fault lines between availability zones are not just important for the hardware itself and how we isolate failures of power, networking, cooling, water. They actually also give us a framework to operate within. And they turn out to be a really, really helpful mechanism, because we know we can tolerate the failure of an AZ and still continue to serve requests without you ever realizing. And so for that reason, when we deploy, we only deploy to one availability at a zone at a time. Our tools actually only allow us to do it. When we're running routine maintenance or operations, we're only doing that to one availability at a zone at a time. When we're deploying software, config changes, new hardware, anything like that, we go availability zone at a time. It's very much programmed into our engineers, our managers, that you always only operate in a single availability zone at a time. And that way, if a bug is introduced or an error is made, we know we can tolerate that without affecting the entire region, because the availability of that zone does not impact the availability of the region, if that makes sense. Okay, so everything I've spoken about has been device failures. I've also spoken about zone failures, and I spoke a little bit about how we approach or leverage that zone failure boundary to make our own changes ourselves. But we assume that all of those systems are incorrect. That's how we operate. We build them to be correct. They're very robust. The majority of our code and changes and services and tools we actually have are all around maintaining that correctness, but we assume it's incorrect. And we have additional guardrails to kind of help us mitigate any the issues from any changes we make. Two quick examples of these. The very first one is control plane limits on new hardware. So when we introduce new hardware, as I mentioned, we only do it one availability zone at a time. So we introduce that new hardware into an availability zone, a single availability zone. However, our control plane also only allows your objects to be, our control plane also prevents the data for your objects from being disproportionately placed on this new hardware. And that's, again, if there's an issue with this new hardware, we can still retrieve your data from other disks. So our control plane goes a little bit further. If you remember the repair process I spoke about earlier, that repair process understands this is new hardware, and it does not disproportionately load objects on or shards onto this new hardware, so that if there is an issue with it, we can still reconstitute your data from other drives. Shadow mode is also another guardrail we have in place, and we use it quite often. It's also called metrics mode. It's basically where we will deploy a large-scale change that doesn't necessarily have external side effects and run it alongside existing code. So you can imagine sometimes we're processing requests or processing metadata on a request. We deploy a new change. We'll also process that metadata using the new code at the same time, but we will not persist those changes with the new code. What we can do is we can emit metrics for that new change, compare the results of the existing code versus the new one. If there's any strange oddities, we can pause and then fix the code before we deploy out. Once we see that all the metrics are the exact same, we know that this code is safe to deploy, and so we'll deploy it at large. So this takes a lot longer to get code out there because of this, but it also gives us a lot of confidence that at the scale we operate, the change is very, very safe. Okay. So I've talked a little bit about the failure domains. I've also talked about the guardrails we have in place. I want to talk a little bit about the history of the service now, which is an interesting one. So S3 is a global service, but we're regionally isolated. So we operate across all AWS regions in at least 3+ AZs. So again, that allows us to tolerate the failure of any availability zone in any region. But I want to come back to that statement earlier. We must protect data we store against the unexpected loss of an entire zone. We assume that any single facility may fail at any time and that we must still protect the durability of the data that's stored within it. That threat seems pretty easy with how we're structured today, because again, when AZ goes out, we're able to tolerate it. But I wonder if anyone actually knew that S3 started out as a global service. So between 2006 and 2010, we had 2 regions, but they were represented as a single endpoint or a single storage service. This is on the East Coast, we had Washington, and on the East Coast we had Virginia, and on the West Coast we had Washington. And this was part of our vision for the time. We hadn't really figured out regional isolation. It was a process over time that we figured out. So we wanted to be a global service. Part of this was how websites are presented. For example, they're presented as a global resource you can access, and so we wanted our storage to mimic that. But we realized that this came with some drawbacks. When you were putting data here, the bytes would live ultimately where they arrived. So if you put them in close to Washington, they would live in Washington. If you put them close to Virginia, they would live in Virginia. So they only lived in one place. The index, which allows us to go and look up where the data is and access it, was actually replicated between the 2 regions. But it was eventually consistent because we were replicating that data. So some issues with that: the eventual consistency of the index, also the latency that was introduced. If you were trying to access the data in Washington, but it was stored in Virginia, again, you didn't know where the bytes were. They just lived wherever they arrived. And then secondly, if there was any issues with the internet at the time, the availability of that data could be impacted if you're trying to retrieve it in Washington, even though the bytes are stored in Virginia. So that's really when we started then pivoting to regional isolation. At the time as well, EC2 was gaining momentum, and so the way, for performance reasons, to access your storage, you always want to access it locally. But we realized that even though global storage was not the way we wanted to build S3, it was still important to give you the primitives you needed to build a global storage. And so for that, we launched S3 replication a number of years ago and S3 multi-region access points. S3 replication allows you to replicate that data globally into different buckets, and S3 multi-region access points gives you a simple routing layer or routing construct on top of that that you can use to route requests over the globe. Okay, I'll just do a quick recap. That was a lot of information to condense into a couple of minutes, but the main thing about it I wanted to convey is that this has been a learning process all the way back from 2006, when we learned how to regionally isolate and that we wanted to, then how we learned about how to manage disks and how they fail, how availability zones fail. There's many different ways: power, water, cooling, lots of different ways they can fail. And it's quite complex, but it's become part of our culture, our DNA. It's how we think. The fact that we only think about the failure of an availability zone, and so we'll only operate in one availability zone, is something that has come over time. Hopefully these were helpful to you and to think about how you deploy your own software, how you manage your own operations. That's exactly what we've done over many, many years of S3. Okay, I have taken us on a voyage through the 11 nines of durability. I think Rob is now going to chart a course into beyond 11 nines.
Excellent. Yeah, we spent a good amount of time on this talk, and in order to go beyond 11 nines, we may as well start with 11 nines and go from there. Excellent. So on this next slide and in this section, we're going to build on the foundation that Ian laid out, which is choose Amazon S3, store your data, you get 11 nines of durability across all our storage classes. There are things like one zone infrequent access or express one zone where it's in a single availability zone. We'll talk about how you can add additional resilience for things. But even with that 11 nines, there are things that can happen to your data, because if you send us a deletion request or you have lifecycle running on your data, that's the relationship we have as a provider and a customer. If you want to delete your data, we're going to delete your data. If it's authenticated, authorized, we're going to process that deletion request. So if you want to protect against those scenarios as well, that's where we're going to talk about additional features. So when we talk about our data protection objectives, first, we want to protect against those accidental deletes. That can be things like accidental deletions, overwrites, maybe a lifecycle policy that's configured incorrectly, wrong number of days, things like that. We also may want to build additional resiliency against things like bad actor protections and maybe regional issues that affect our data availability. And then that last part here, talking about governance compliance requirements, depending on where you were storing your data previously, if you're not in the cloud today, there may be requirements to store multiple copies of your data, to separate them by a certain number of miles, different geographic regions. We see that from a lot of customers, and using tools like what Ian said with replication, you can achieve that end goal by building out your storage in a way where it has that regional resiliency built in. All right, on this slide here, we're going to explore the fact that data protection and security, there is a bit of a blurry line between the two. And talking to folks ahead of time, thinking about IAM roles, permissions setups, things like that, there are a number of best practices you can put in place on the data protection and security side that are going to benefit you really in both realms. So as we look at this, it's really a multi-layer model, and there's a number of things you can do as a customer. Using least privilege access with IAM policies is a best practice. That's going to restrict the number of people that can make mutations to your data and to your environment. Next, multi-factor authentication. It's a feature that has benefits on both the bucket configuration side, but also requiring multi-factor authentication to do any deletion of your data. Let's say you have critical data to your organization. No one should ever delete that data. We'll talk about a number of features that can protect against that. Multi-factor authentication is certainly one of the best in terms of how difficult it is to then have an accidental deletion event. Next, immutable backups. So looking at things like object lock, where there's a number of different settings for object lock, but between governance, compliance, and legal holds, being able to enforce the fact that this data is going to be retained until a period of time or until that object lock legal hold is removed. You've got encryption, so this is where we're talking about both security aspects and data protection. So on the security side, making sure access to your data is restricted. You've got encryption to protect the data at rest. You've also got things like the AWS key management service to make sure that somebody needs not only permission to read the data, but needs the ability to decrypt the data and have access to your KMS key for it to even be read successfully out of S3. So it gives you that additional layer of security protection for your data. Next, looking at that physical security, digital separation of roles, that's not having the same role that can access my primary copy and my backup. Because if they've got access to both of them, then the same error could potentially happen in both places. As we talk about physical security, that could be for an MFA token, that could be in other ways in terms of how you store copies of your data. And then the last one here, audit tracking. I didn't mention it earlier, but as we talk about that continuum of data protection, you've got not only features that you can just enable to store additional copies of your data or protect it against accidental deletion, but we're going to talk about a number of tools like Trusted Advisor, Config, Storage Lens. How can I audit changes to my environment? How can I understand maybe the cost implications of turning on different features, and how can I monitor my spend? How can I monitor things like what percentage of my data is being replicated? We have tools that allow you to do that in aggregate, so it's very easy to see in a snapshot view of how buckets are configured, how data is being protected across your environment. So all of that is part of your backup story, data protection story, and now we'll jump into even more of the details as we weigh anchor and head off into the distance. We're going to sneak in more and more nautical references for you. You'll see why later. Okay, so on that continuum of data protection, we'll go into all these features in various levels of detail. So keep these in mind. We'll come back to them. We'll talk about them later on if you have questions after the session. But as I talked about, some of these are in the same bucket, and some of these offer cross-account, cross-region, and multi-bucket protection. So starting with our first one, versioning. I'm sure many folks in the audience are familiar with versioning, but we'll go through all the subtleties of it today. So that's a setting you can turn on for a single bucket. Great. That's really level 1 of data protection in S3. This is more critical data. I want to have some level of protection. Let's turn on versioning. Just day 1, turn on versioning for it. Comes with a lot of things right out of the box. Next, multi-factor authentication, which not only controls the versioning status of a bucket, so you can have MFA protection, make sure nobody turns off versioning. That's a nice synergy between those two, and that's something you can use as an additional layer of protection. And then last, we talked about object lock. Object lock, we'll go through a few of the settings and details later on, but it's really cost effective. It's free if you enable it when you first store an object in S3, and then because you can configure the days or use things like legal hold, it's absolutely configurable by you. I'll mention it now because I love this example. But let's say you store log files in your environment, whether you're centralizing them in a single bucket or you've got buckets throughout your S3 footprint where you're storing logs. If know that every log file is stored for 30 days. No questions asked. Every log we take 30 days at least. Maybe it's longer for some logs, but it's always 30 days. Turn on object lock on all those logging buckets. Make sure they're all locked for 30 days. And then there's never going to be a moment where you go to look for those logs and go, oh, I can't believe someone went in and cleaned out that bucket. Like, because it's a free protection, it builds on top of versioning. It's something where you can pick that number, whether it's 4 days, 7 days, 30 days, 90 days. Whatever the number is, it's a bucket level thing. Stamps every object with an object lock setting when it's stored. And that just ensures that level of data protection. So I love that example. It's very simple. There's many things you can do with object lock, but that to me is one of my favorite examples. All right. If we want protection across multiple buckets, multiple regions, and then I love the cross-account aspects of this as well. We'll explore it more in later detail. But when we talked about nobody should have an access maybe to the primary data and the special from everybody, having that ability to do that with these features is great. I see a few folks pointing at their headphones. I'll look for a signal from the back. Are we back? Let's check again. I'm getting a thumbs up from the back. Excellent. OK, so some folks still give me a little wavery. But I will go back. I'll recap. Object lock we'll explore a little bit later in detail. And then for multi-bucket, cross-account protection, we're going to talk about S3 replication. We'll go through examples there, how you can do things like delete marker replication. One of the folks was asking about that earlier. You want two buckets to mirror each other. Replication, turn on delete marker replication. You'll have that across both buckets and really mirror the two. Or you can have a more isolated second copy. All right, so S3 replication gives you that multi-bucket protection. Same thing with batch operations. For folks not familiar with it, I'd say the most common use case we see is using replication with batch operations. So I turn on replication, it starts replicating all my new data. But then I have that moment where I realize, well, I have 15 terabytes of data in this bucket. I need to replicate that too. Batch replication is a feature that allows you to do that. You turn on an easy filtering, say replicate all the existing objects in this bucket. Now you've got everything replicated, and moving forward, everything's protected in that bucket. So batch replication works really well with replication. And then we're going to talk about backup solutions. Partner solutions, that's AWS services. And that gets you a very isolated backup because it's not managed by you. It's not something in your environment where you're trying to get the IAM permissions correct. That's a AWS service or a partner solution that is maintaining that backup for you and restricting who has access to it, how you restore from it, et cetera. So all of these things work really well together. We're going to cover them in detail. All right. The other things I mentioned earlier, how do you audit this? How do you make sure the right settings are configured on your different buckets? We'll go through all of these in detail. We'll talk about examples for each. I really enjoyed going through the documentation in detail for each of these, going through prepping for the presentation. But these services are adding more and more protections every year. It's one of those things that if you took a look at, let's say, config a few years ago and set up config rules, might be a good time to go back and look again because there's more and more things that these services are constantly adding to help you monitor your AWS environment. All right. The way we're going to structure this part of the presentation, we're going to go through a few different examples, starting with accidental delete protection and covering overwrites, accidental deletes, and lifecycle. We'll talk through all those scenarios, and then we'll cover each of them in terms of mitigations, how you can audit them, what the threat is. So we'll walk through each of those, keep taking pictures along the way, but this is something that we really want to give you the tools and ability to monitor these things and have the best practices to control costs when you turn on all of these for your S3 bucket. So from an overwrite standpoint, you've got this amazing image. It's very important to you. You're a big fan of submarines, and you've got it stored in your bucket. And then one day, overwrite is a risk, and suddenly you have a tugboat. That's not exciting. That's not what you wanted. That's a toy. That's not a cool submarine. I'm even going to go back so you can see the submarine again. Yes. All right. So we need to protect against overwrites because we have valuable data. We don't want to lose it. And then from a deletion request and lifecycle standpoint, we don't want objects to no longer be there when we expect them to be. That could affect our end users, could affect any application that's relying on data. So we want to protect against all these scenarios, and that's what we're going to do. Overwrites occur when you're overwriting objects with the same key name. Very simple. Cat JPEG is an example later on, submarine.jpg, any type of file that's being uploaded. And importantly, talking to different customers, we have a lot of customers that add randomness to data as they store it in S3. So hey, I always store unique key names. I have some sort of dimension of time applied to it. Every object should have a unique GUID or something else applied to it to make it unique. That's good, and that's an application, design you might be choosing. But if there's an error in that process, and for some reason 1 out of every billion objects has the same key name, it's going to overwrite it, and if there's no versioning turned on or anything else, that overwrite, that original data is gone. So just saying your design doesn't overwrite data is not enough. We want to build on top of that. And then there's also the risk that, yes, I made sure this application's audited and is never overwriting data, but what about the next client that spins up? What about the other applications that use that bucket? There is the risk of collisions, so we want to protect against overwrites. All right, first thing we're going to do, I said base level 1, what you can turn on for an S3 bucket, that's versioning. Turn on versioning has so many benefits right off the bat, and let's talk about them now. So for versioning, every new write of the object with the same key name just creates a new version. Very simplified example here, but version 1, version 2, version 3, that can go to many, many versions. We've seen examples of tens, hundreds of thousands of versions of a particular object. It's not common, but it can happen depending on how your application works. So when you turn on versioning, you get a unique version ID for each of those objects. That means you can read any unique version ID you want. If you want to go back and read the first version you wrote, just specify the version ID, you'll get that version. What happens when you turn on versioning is not only do you get that overwrite protection, but any deletion request. So if I go in and delete cat.jpg, if I don't specify any version ID, it adds a delete marker. So instead of removing something from the bucket, it adds a delete marker. What that does is if I go to get cat.jpg afterwards, it'll give me an error because it'll say object not found. Those versions are still there, but they've got a delete marker that was written on top of them. You can then use specific version deletes at any time to remove the delete marker, to remove specific versions. But any deletion without that version ID specified leaves all your objects alone and they're maintained. But you're going to have cases where you want to delete specific versions. You're also going to have cases where you want to get rid of these objects. From a cost standpoint, having versioning on and keeping everything forever is usually not common for all buckets. So you're going to have a cleanup policy. You're going to have things like that. Versioning, bucket level setting. You can monitor that non-current version storage. So I talked about a simple example earlier. I'm overwriting files and then I'm adding delete markers. If you keep all of that data over time, you can then look at the metrics in Storage Lens and see easily, well, what percentage of my bucket is current versions, the newest thing I wrote, and what's that non-current version? So if you're overwriting objects repeatedly, you may get to the point where more than half of your data is non-current versions. That makes sense for some applications, but not for all. So you can easily set up a lifecycle rule saying after something's overwritten, after a day, expire that object. After 7 days, remove my old versions. And I'm very excited that we launched this a few years ago, but you can specify a number of versions filter for lifecycle. So I always want to maintain my current version. I want 2 non-current versions, so the last things I had before I overwrote the object. But then I want to clean up everything else. And that allows you to say, across your bucket, you may have millions of objects, some of them overwritten very frequently, and some of them never overwritten. So then you can set up the rule that the one that gets overwritten every hour throughout a day, it's adding up new versions all the time. Set up that rule to limit the number of versions in a bucket. Very easy to just clean up files, but have some rollback period for any application. Something was deployed, you want to roll back to a period in time, you'll have all those versions stored, you could easily make that change. And I put a little check mark here at the bottom, but I think it's interesting for customers to keep this in the back of their mind. Lifecycle in general works on creation date. Object was created, on the 1st of a month. I have a 21-day expiration policy. On the 21st day, it's 21 days old. That's when it would apply. Non-current version policies work on when the object was overwritten, which I think is awesome. I just love a lot of the decisions that were made. Ian talked about so many design things about S3. But I want to expire that object after 4 days, maybe after it was overwritten. So yes, that object was overwritten. It's been a few days since. We haven't had to roll back. We don't need that object anymore. I can expire it after 4 days after it was overwritten. The object might be 5 years old, but I want it to trigger after so many days of being non-current. And I think that's really nice that you can just set that up directly in S3. All right, so Trusted Advisor here has a way to see which buckets have versioning turned on, which buckets don't. I think in this case, I have 13 out of 28 buckets that don't have versioning turned on. I might log into Trusted Advisor and say, oh, that makes perfect sense. I didn't need versioning on those buckets. Or this is something that then prompts me to take action, look deeper into it, identify which buckets. So if you're going to apply this at scale, this is a great way to see exactly what buckets have those settings enabled. You've also got a replication visibility here. So that's something when we talk about that feature later on, you can. On the AWS config side, you'll see MFA, you'll see other things. But here, does versioning enabled. So I set up a config rule, and if somebody's creating new buckets that don't have versioning turned on, I'm going to get an alert. This rule is not going to be satisfied, and I'm going to know very soon after that bucket was created. So customers certainly use things like Terraform, CloudFormation, et cetera, to create new resources and apply best practices to them. But this is a great way to build audit protection on top of that to make sure everything in your environment follows the design practices you want. All right, on the storage lens side, we've got metrics for versioning, replication, object lock. The free tier includes 14 days of data. I love the free tier of Lens. If you haven't tried it before, go home and try it today. I've got a slide that talks about what's in the free tier and advanced tier. Both of them are extremely capable. Advanced tier adds a lot of new visibility, but the things that are in the free tier is really impressive. And it really does mean free tier. It's free. Take a look at it, use it, completely free. So you've got data protection metrics at the bottom there. The advanced tier includes 5 months of data. So when you turn on that advanced tier, you get additional metrics, but you also get more retention of your historical metrics. So you can go back and look at that. All right, non-current version bytes, monitoring that, understanding the overwrite patterns of a bucket, and then setting up the right expiration rules so you're saving money along the way. And then on the advanced tier, you see things like the rule counts that you can get visibility on, counts of delete requests, et cetera. A lot of great visibility for you. So the other thing for protecting against accidental overwrites, and this is brand new, we talked about some things that are net new in 2024, using conditional if none match. So what that does is for every new put to your bucket, it's going to check if something's already at that key name. So it's a condition you're setting on a request level to say, I want to make sure everything's unique to this bucket. Great for concurrent writers writing to S3, but also kind of nice for data protection purposes. And then very, very recently, in the last week or two, we added an enforcement to say, I want to make sure all new uploads to my bucket have that conditional protection enabled. So that ensures that nobody's writing to this bucket without that if none match condition, so nobody's overwriting anything. You could use that with versioning, you could use that without versioning, but it's a way to put a request level check to make sure nobody's overwriting data. All right, so it checks for that existence of an object. It's a per request thing that you're setting that for every request. You want to set it up for all new buckets. And then it's a bucket level setting to enforce that. We've got other conditions we launched, things like an e-tag match. So you've got an application updating a file in S3 and making sure, well, I want to make sure that file is exactly the bytes that I mean to update. Putting that e-tag match on all new requests will make sure that everyone is checking, oh, it's exactly the version I think I'm overwriting rather than something else was written. For simultaneous writers, these condition checks are awesome. But something like, for a bucket where you don't expect a lot of frequent changes on configurations, things like lifecycle policies, things like your bucket policy, you could use CloudTrail to set it up for management events, data events, and those management events, like those bucket level configuration changes, you'll have an easy way to see, oh, that popped up in CloudTrail, I see that, I've got things set up to look for those changes, and then you can audit that. So it could be a two-person review ahead of time, or it can be a monitoring for any changes that are unexpected and you want quick alerts on those. We talked about later on single bucket protections, just spent a ton of time on those. But you may have requirements where you need multi-region protection, or you may want additional resiliency that multiple regions offer you. So we're going to go through replication, batch operations, and backup solutions. Some of these will be quicker than others. What we find with customers is there's so many different flavors. For some customers, it's replication to a different account, different bucket, low-cost storage class. No one's ever going to touch it. And for other customers, replication's part of using multi-region access points and having availability such that any request is routed to both regions, and if any region is offline or unavailable for any reason, it just reroutes. So we see replication used in a variety of different ways. As we look at replication and the different features available, you've got same region and cross-region replication. When we added same region replication, I'd say about 5 years ago, it gives you a very low-cost way to replicate your data because there's no data transfer charges, and you can have a local copy that can be isolated, can be in a different account, but is within the same region. So it gives you some benefits when you do that. You can choose to replicate to different storage classes for low-cost storage. You can do that cross-account or to multiple destinations. Another one that we launched just in the last, I'd say, 3 or 4 years All the memories of great launches kind of blur together sometimes. But being able to replicate your data, not only a copy to Europe and to Asia, but to maybe different buckets within the same region and cross-region. You have that flexibility. I think the limit we've set is you can replicate, a copy per region. So it's a fairly generous level of how many configurations you can set up for a particular bucket to replicate to. Progress tracking, we'll go through some of the metrics examples, and then we'll talk about how you can get SLA-backed replication with replication time control. So I have critical data, it's uploaded to Northern Virginia, and I want to make sure that within 15 minutes I've got a copy in Oregon. If anything happens, I want to make sure that data gets to Oregon very quickly. Replication time control is the answer for you, and then you'll have metrics to make sure everything's replicated in a timely manner. All right, we'll go through some examples here. We'll talk about configurations. Some folks asked questions earlier about enabling delete marker replication, for example. So US East, US West, simple example here. You can see you're enabling replication. You've got that delete marker field there, right, in the configuration, so you can see how that's set up. Delete marker replication, what that means is if someone deletes something in the source bucket, they issue a delete request. Do I want that also to be replicated over to the destination region? Or do I want that destination copy to be isolated and have no deletions or anything else propagated to it? You have the option to toggle that on and off. You specify a name for the replication rule so you can easily come back later on and edit it, and you've got the bucket that it's going to replicate to. In this case here, we've got a destination storage class that's different from our source one. Might have standard data in the source, but we want that Glacier Instant Retrieval price point in the destination. Typically, you have a destination where not a lot of people are reading the data, so low-cost storage classes make a lot of sense. You'll see easy to specify there. Here, we're going to talk through the cross-account example, so account A, account B. And once again, very easy to set that up, specify the bucket, specify the account, and specify things like storage class, delete marker replication. Another example here, talking about how replication works under different failure scenarios. Primary copy, secondary copy. So we talked about batch replication earlier. You've got that possibility not only to replicate existing objects, but if there's any failure. So somebody sets up a new replication rule, the permissions are not correct, it has failed replication for some number of minutes before you identify that. Use batch replication to then go back and re-replicate those failed objects. Replication retries. It's a persistent system. It's got a number of checks and balances in it, so it's going to replicate everything if the permissions are correct, and it'll keep trying until it succeeds. And then lastly, in the case of a misconfiguration or permission error, that will be a terminal failure. That will be something that's permanent until you use batch replication or copying it in place, for example, to re-trigger replication. Those metrics that we talked about earlier, great to picture them, but it'll show you how many minutes of replication latency there are between the source and destination, how many bytes and objects are pending replication, so what's the backlog of things that have landed and not yet replicated, and then the last one there is objects failed replication. So this is the one where you might want to set an alarm on just, if there's any failures, I want to know about it right away. You can set up events and metrics to see that. Replication time control, the SLA is for 15 minutes, and then it gives you an event if anything's delayed past that point. So that's a nice benefit there, that you get that SLA back for 15 minutes, you get a note, you get a missed threshold event if it's delayed, and you get a second event when it's actually successfully replicated. So it gives you ways to instantly pipe that into other parts of your system. Batch operations gives you the filters that you can use, or you can submit a list yourself, but this can be used with batch replication to make sure you get those existing objects, failed objects all replicated successfully. That is something where you can use a custom manifest. You can use an S3 inventory to specify the objects. And then the best practice here is there's a way to see the size of the job before you actually do batch replication or another operation in batch operations. All right, backup solutions. We'll go through this briefly. We're right at the end. Back up your data to another AWS account. It's managed by the service. It's completely isolated. And then it gives you abilities to recover to a point in time. You can do continuous backups. You can do periodic ones. But all of these solutions, whether they're AWS or partner ones, give you a number of different configuration options to make sure the cost of the backup makes sense to you, and you've got the abilities to recover in a way that makes sense to get to you before that error might have happened. So choose the right data protection features. Make sure those are the default moving forward for new buckets. audit and alarm on changes and unexpected ones that might happen, and then regularly revisit those settings. I talked about going back to features earlier to see what's added. What's new to AWS Config? What's new to Trusted Advisor? Recommend you go back, take a look at those. You can continue your learning with Skill Builder and increase your knowledge with all the training that's available. So you got a QR code there, you've got an easy URL to lean on. And then without further ado, Ian and I would like to thank you for coming today. Thanks for going on this voyage with us. Thanks for joining us and learning all the different ways to keep an eye on your S3 storage and protect it for years to come. And then right side there, always remember to fill out those surveys. It really helps us. We spend time each year looking at survey results from last year or our own sessions and saying, we've got to add this, we want to remove this, we want to spend more time here. So please all do that, and appreciate you taking the time to join us today. Thank you.